in this problem we have 3 parts we're multiplying together, and whenever we have the multiplication of 3 variables, we have to add together the exponents. So let's create some addition over here on the right side. We've got 3 divided by 20 plus 1/4 plus 2/5. Now to add all these together, we have to have a common denominator. So you're saying, well, how do we find that? Well, what would be the smallest common multiple between 24 and 5? So basically, what number does all 3 of these divide into evenly? And that's going to be 20. So if we write down the denominators down here, all going to be 20. 20. That's another 20. We need to fill in the numerators. So this is going to just switch down here. 3 over 20 is 3 over 20. But what do we have to multiply 4 by to get 20? And that's going to be 5. So then if we multiply this 4 by 5 to get this 20, you also have to multiply the top part, because you don't want to change the value, you just want to change the way it looks. So by multiplying 1/4 by 5 over 5, which is just 1, that doesn't change the value. So we've got 5 times 1, and that's going to be 5 up here. And then what times 5 over here gives us this 20, and that's going to be 4. So you multiply the top part by 4 as well. 2 times 4 is 8. And there we go. We've got our 3 new fractions that are the same as these 3 fractions up here. But they look a little different. So now 3 plus 5 is going to be 8, plus another 8. That's going to give us, 16 over 20. And then 16 over 20 reduces to be, well, 4 goes into 16 4 times, and then 4 goes into 20 5 times. So this is going to be 4/5. So multiplying these all together, that's going to give us x to the 4/5 power, and that is our final answer. Now if you look down here, we have another expression that we want to simplify, and the problem with this one is that there's a fraction as an exponent in the denominator, so we want to get rid of that. So what do we multiply x to the 2/7 power by to get a whole number which will get rid of this fraction? And that's going to be, if we have 2 7s here, we'd want to change ink colors here, multiply it by x to the it's going to be 5/7 power, because 2 7s plus this 5 7s over here, that will give us 7/7, which cancels out that fraction, and that's the main part of that problem. So if we multiply the bottom part by x to the 5 7s, you got to multiply the top part by that as well. And then let's continue simplifying down this way. So we've got 2 to the x times 5 7s power over, that's going to be x to the 5, it's going to be actually a 7/7, which will just be 1. So x to the 1st power in the denominator, and this is written as a fractional exponent in the numerator. That's okay, and I just wanted to rewrite this again so that you could also write it as a radical, and that would be making this denominator of 7 as the index. So you could also do 2 times the 7th root of x to the 5th power, all divided by x, and that would be a final answer as well. So you could keep it like this in the numerator, or you could make it look like that. Either way is okay. Now in this final example problem, we have something a little bit different going on, because we're raising everything in parentheses here to the -1/3 power. So just like I said, raise everything to the -1/3 power. So I'm going to write this starting out as equals b to the -18th power and that's going to be to the negative 1/3 power. And then down here in the denominator we've got 216, and that's going to be raised to the negative 1/3 power. And let's simplify from there. So let's see, there's more room. Alright, so whenever you have a power raised to another power, you multiply. So if we have b to the negative 18th power raised to the negative 1/3 power, you'd multiply negative 18 over 1 times a negative 1 over 3. So multiplying these two together, you get negative 18 times negative 1 is positive 18, divided by 1 times 3, which is 3, and then 18 divided by 3 is 6. So we have b to the 6th power up top in the numerator, and then down here in the bottom we have 216 to the negative 1/3 power. So we don't want a negative power, so you move that to the other side of the fraction bar, and you can make that positive. So I'm going to get rid of my fraction bar because I'm moving this all the way to the numerator again. So I have 216, and that's going to be to the 1/3 power. Now, if you know something to the 1/3 power is cube root, then you could go ahead and take the cube root of 216. Or if you don't pick up on that right away, I'm going to write b to the 6th again, and then you could change this into radical form to see like what root are we actually taking of 216. So this 3 becomes the index of the radical. So you're going to find the third root of 216, and then this one up here, that's the exponent. You don't have to write that at all. If you don't want to, it's invisible, but you'll see like right here that we're taking the cube root of 216. So let's go ahead and do that, which will be 6, and then we're multiplying 6 by b to the 6th power, and that is our final answer. So just to kind of recap, what we did over here is raising everything to the 1/3 power, and it's going to be negative. So we do that up here and then down here. Negative times a negative, that gave us a positive answer. So we kept that answer up here. But because we have a negative exponent, let's move that to the numerator, and we can make that positive. And then just simplifying a little bit more, you'll find out that we get 6 times b to the 6th power is our final answer. And that's that.